So now it is time to finish up with Unit 4, which is with Lesson 4.7, understanding the concept of absolute value, the distance from 0 to whatever number we're talking about, and being able to carry that over into plotting points on a coordinate plane and finding their distances. So when we start looking at our expectations, our goal, our objective for the lesson, we want to be able to use our coordinates, once again, in the X, Y order, plot them, and then find the distance between these 2 points on a coordinate plane. So when we start doing this, we first have to find the coordinates as an ordered pair. So when I find a point and I figured out what the ordered pair are, then I want to compare the x-axes. Once again, axes, A-X-E-S is plural for axis. So we should have two ordered pairs, and we can compare the two x coordinates and then the y-axis, comparing the two y coordinates. Then we're going to do the correct math with the coordinates that are different. So if I have 2 points that are straight across from each other, then that means either the x's are going to be the same, so I have to do the math with the y's, or the y's are going to be the same, so I have to do the math with the x's. Figuring out what math to do is the key. So when we look at examples of what we're talking about, then we can see that we have these 2 points on this graph, and we see their ordered pairs are -5, -4, and the second one is -1, -4. Notice that the y-axes are the same number. Both of the y's are -4. Therefore, I focus in on finding the distance between the -5 and the -1. So once again, it's going back to the idea of absolute value, which was in lesson 4.2, and finding the distance between the numbers. Now, when I'm looking at them then, once again, I have to be able to figure out, am I going to add or am I going to subtract? So this note is important. As I was talking to some students today, and I asked if they wrote down the key points to the lesson, they're like, no, I didn't for lesson 4.6. So please write down these notes as we're going through them, because these are the keys to understanding how to do this math. When the points are in the same quadrant, so they're both going to be in quadrant 1 or quadrant 2 or quadrant 3 or quadrant 4, that's what it means, then I'm going to subtract the absolute values of the coordinates that are different. Both of these points are in quadrant 3 because they're both negative, negative. Both of them have the same y-axes because they're both -4. Therefore, I'm going to focus in on the -5 and the -1. I want to find the absolute value of both of those numbers. Once again, because they're both in the same quadrant. So the absolute value of -1 is simply 1, and the absolute value of -5 is simply 5. So if I know that they're in the same quadrant and I'm going to subtract the coordinates that are different, then I'm simply going to subtract 5 and 1. It doesn't matter which one you have listed first in your work, just understand that when I'm subtracting these, then I have to subtract the smaller number from the bigger one. So even though in the book they're showing you the -1 absolute value is 1, first I have to take that from 5, because if I hold up one finger, I can't take 5 from it. So if I have 5 minus 1, then we know that these are 4 units from each other. Units is the correct label unless they give me a label that each of the blocks or units in my coordinate plane are equal to. Now, when I look at this one, I'm going to have a new note to write down because there are two different understandings that we need to have when we're doing distances on a coordinate plane. This one says when points are in the opposite quadrants. So in this example, we have 2 points. One's in quadrant 1 and one is in quadrant 2. Then I'm going to find their absolute values and I'm going to add them together. I have one coordinate that is still the same, so I'm going to leave it alone. and then I have one coordinate that is not. One of them is probably going to be positive and one's probably going to be negative. So therefore, I need to add their absolute values together. Looking at those points then, I can see, once again, one is in quadrant 1 and one is in quadrant 2, that their y-axis coordinate is the same. So I'm just going to leave it the same and focus in on the x. The x-axis I have are opposites of one another. One is positive, one is negative. So since one is positive and one is negative, then I need to add their distances together. The absolute value of negative 4 is 4, and the absolute value of 1 is 1. So 4 plus 1 is 5. What that is meaning and what we're getting to is the idea that if I go from negative 4 up to 0, right, my y-axis, then I've gone 4 steps. And then I go one more step to go to positive 1. So it makes sense that if I am counting the units or I'm counting the blocks, that I would be going 5 different blocks, or 5 units would be the correct label. So when I'm doing these, I have to just simply follow those 2 notes and pay attention to what I have. Now on this particular example, it says to identify the ordered pairs for each point. So there are times that are just going to say, okay, there are these 2 points, give the ordered pairs for them, right? They go in the order of x, y, separated by a comma inside of parentheses, and then find their distance. So when I look for u, I can see that I'm going forward 1 unit, which is going to be a half, and then I'm going down 3 units or 3 blocks, which is negative 1.5. So my ordered pair is going to be 1/2, negative 1/2. For V, I'm going forward 4 units, which is equal to a value of 2. And then I'm still going down the same distance, so I'm still going to go down negative 1.5. So when I start looking at their values then, I see that my y's are the same, so I ignore those. I don't need to use them. I'm going to focus in on the ones that are not the same. I have a positive 1/2 and I have a positive 2. So my absolute value of positive 1/2 is 1/2, and my absolute value of positive 2 is positive 2. So since they're in the same quadrant, then we know, according to that first note that we took, we're going to have to subtract their values. So when I do 2 minus 1/2, then I have to remember how I'm going to subtract fractions. Remember that you're going to have to borrow from the 2. It'll become 1 and 2 over 2, and then you subtract 1/2 from it. But it should just logically make sense that 2 minus 1/2 is just going to be 1.5. Notice once again that the label that they give you is units. This one says find the horizontal distance between the 2 points that are given. We have point P and point Q. So I want you to try this one on your own. Pause the video, come back and check, and let's see how you do. So hopefully you've done as I've asked. You found your answers, and let's see what you did. Did you follow these 3 steps? Did you find the coordinates of both of the ordered pairs? Did you compare the x-axes and the y-axes to figure out which one you're going to keep and ignore, and then which ones you're going to do the math with? And then did you figure out what math you're going to do? Are you going to add or are you going to subtract the absolute values? Well, when I'm finding my ordered pairs for P, then I know going from my point of origin, 0, 0, I'm going back -5, and then I jumped down to -2. For Q, you start at the point of origin, you went back -2 and dropped down -2. So comparing the x-axes and the y-axes, then I can see that my y's are the same, so I'm going to just keep those and ignore them. I'm going to do the math with the ones that are not the same, which are my x-axes. So therefore, since they are in the same quadrant, they are both negative, then I know I'm going to end up subtracting them because that's what the note told us to do. So I'm going to find my absolute value of -5. I'm going to find my absolute value of -2, and I have 5 minus 2, since they are in the same quadrant, which gives me 3. 3 what? Once again, I need to know that my label on all of these, unless they specify something different, is going to be units. All right, well, what about when we talk about finding distances for the opposite sides, right? So if I find, once again, the ordered pair, notice on this particular coordinate plane, we have 0.25 for each unit, or 1/4. So since they're written as decimals, I want to do 0.25 for the first one, 0.5 for the second one, 0.75 for the third one, and then 1/2 for the fourth one. When I'm finding my ordered pair for E, I'm going back 1, 2, 3 units, which is going to take me to -0.75. And then we're dropping straight down, 1. So that's going to be a -0.25. When I'm finding my ordered pair for F, then I'm going forward 1 unit, which is going to be a positive 0.25, and I'm still dropping down 1 unit, so that's going to be my negative 0.25. Then I compare. Do I have the x-axes that are the same or the y-axes that are the same? Well, once again, in this situation, we have the y-axes that are the same, so I'm going to ignore them, and I'm going to just keep it. I focus in on my x-axes. Those are different, and notice they are opposites of one another. Therefore, they're in different quadrants. And therefore, I'm going to find their absolute values and do what? I'm going to add them. So if they are in opposite quadrants, I know I'm going to add their absolute values because I have to go from E all the way up to 0, and then from 0 all the way up to F. So my absolute value of -0.75 or -75 hundredths is just 75 hundredths. And then when I look at my 0.25 or my 25 hundredths, the absolute value of it is 25 hundredths. So I have to add those together. And once again, when I'm adding decimals, I need to remember how we add decimals, right? So we have this process that we learned way back in lesson 3.2, right, where we had all of the different processes with decimals. I line up my decimals, I bring it down, and then I add starting from the right, going over to the left. And 5 plus 5 is 10, put down my 0, carry my 1. 7 plus 2 plus 1 is 10, put down my 0, carry my 1. 1 plus nothing is 1. So what we're seeing is that my final answer is just going to be 1 unit apart, right? We don't need 1.00 because we don't say 1 and nothing units. It's just 1 unit. All right, so these are in opposite quadrants. So remember what you have to do, and I want you to do it on your own. Come back and check. So hopefully you have an answer, and hopefully you went through the process. You found your coordinates first. So when I found my coordinates for K, I went from 0, 0, my point of origin, to the left, -2, and then I jumped up 1. So do I have a positive 1? And then for L, you went forward from 0, 0 to a positive 1, and then jumped up a positive 1, because we always run, and then we jump. Then for your second step, you look to compare your X and your Y axes. You see that your Y's are, once again, the ones that are the same. So I'm going to keep them and ignore them. Then I focus in and I see I have a -2 and a positive 1. Those are opposite numbers or opposite signs. Therefore, they're in opposite quadrants, and I'm going to have to do what? Going to have to add them. So the absolute value of -2 is 2, and the absolute value of positive 1 is 1. And therefore, when I add them together, I see that I have 3. 3 what? 3 units. Now, once again, all that means is if I start at K, since they're in a straight line, and I count my different blocks or units that I'm going over to L, I should be able to see that I have 1, 2, 3. I do have 3 units. All right, so what about the vertical distances? So everything we've done up to this point has been horizontal. Well, what do I do when the points are vertical, one on top of the other? I do the same math. It doesn't change, right? I still follow the exact same steps. If they're in the same quadrant, I'm going to subtract them. If they're in opposite quadrants, I'm going to add them. So when I see my ordered pairs of 3, -1 and 3, -5, I look at my x-axis and my y-axis and I see if there is any that are the same. My x-axes are the same, so those I'm going to keep this time, and I'm going to focus in on doing the math with my y's. So I find the absolute value of -1, which is +1, and I find the absolute value of -5, which is +5. Once again, since they're in the same quadrant, we keep the steps where we're going to subtract them. 5 minus 1 is 4. So the distance between those is 4 units. And if you go to the top point there where it says 3, -1, and you count how many units or blocks you go down to the second point, you would count that there are 4. Well, what about this one where they're on opposite areas, right? So I have 1 in quadrant 1 and 1 in quadrant 4. Well, it doesn't matter. I'm still going to go through my same steps. I'm going to look at the ordered pairs. I'm going to notice that my x's are the same, so I'm going to keep it and ignore them, and I'm going to focus in on my y's. I have -4 and I have a +1. I find those absolute values. The absolute value of -4 is 4, and the absolute value of +1 is 1. And since they are in opposite quadrants, since one is a positive and one is a negative, then I know I have to add them together. Because once again, I have to go from the -4 up to 0, and that's 4 steps. And then from the 0 up to 1, that's 1 step. So 4 plus 1 does give me 5. So the distance between the 2 points is once again 5 units. So now, when we start looking at these, we see that, well, I don't have a coordinate plane. All I have are points. That's okay. You don't need coordinate planes to do these. All you need is the points. So if I just focus in on doing the steps and following the math, if you want to plot them, you can, but it's not needed. When I look at them, I'm going to go through these same 3 steps each and every time. I'm going to look at my 2 ordered pairs. I'm going to look at my axes and see if there's any that are the same. I see that my x-axes are the same, so I'm going to keep them and ignore them. I'm going to do my math with my y-axes. I see that they're both negative, which means that they're both going to be in the same quadrant. What quadrant are they in? Well, both of these points have -, and -, is always going to be quadrant 3. So then, if they're going to be the same, I know since they're in the same quadrant, I'm going to subtract them. Therefore, I find the absolute value of -2, which is 2. I find the absolute value of -1/2, which is 1/2. And then I simply subtract them. Now, subtracting fractions. Once again, how do we do it? I kind of walked you through it a minute ago, but when I actually look at the math that we did, we borrow from the whole number of 2, we make it a 1, and we carry over 2 over 2. Then I have my common denominator, I keep it, and I subtract 2 minus 1 is 1, and I bring down my whole number of 1. So I end up with an answer of 1 and 1/2 units. Once again, same label each and every time. So when it comes to this particular lesson, if you forget how to borrow and want to do mathematically with fractions, then you can go back and review lesson 3.3b, which is where we did that lesson here just a couple weeks ago. All right, so I want you to try this one on your own. Come back and check with me and let's see how you did. So hopefully you realize you didn't need a coordinate plane and you just tried to do the math, focusing in on those 3 steps. First, you have your ordered pairs, so you don't need to find them. Second, you compare your x and your y axes. You see that your x axes are the same, so you keep them and ignore them. So that means you're going to do your math with your y axes. They are both negative, so they're both in the same quadrant, which tells me I have to do what math? have to subtract them. So I'm going to take my absolute value of 2/3 or negative 2/3, and it's 2/3, and my absolute value of negative 1 1/3, which is 1 1/3, and then I'm going to subtract them. So when I subtract them, I have to borrow from the 1 because I cannot take 2 from 1. Do you see that? Because you can ask yourself, notice you have your common denominator of 3. So if I look at my top number, I have 1. And if I hold up one finger, I can't take 2 from it. So I have to borrow. So when I borrow, my 1 becomes a 0. And I'm adding, once again, 1 whole to it. So 1 whole is the same as adding 3/3. Same denominator, I keep it. 1 plus 3 is 4. Now, I'm going to teach you a shortcut to this, right? So there is a shortcut, and I kind of mentioned it back in lesson 3.3b and 3.3c, and I was waiting, but here's what the shortcut is when it comes to borrowing and creating your new fraction, okay? So when I'm doing my shortcut, then I'm going to borrow from my 1 whole, which is what we did before. And then I'm going to do this process. I'm going to add my numerator and my denominator and get my new numerator. And what that means is whatever my denominator is, I'm going to add it to whatever my numerator is, and that's going to give me my new numerator. That's what the little n and the big N means. And then I simply keep my original denominator. So what that looks like here is I'm going to add my denominator of 3 to my numerator of 1, which gives me a new numerator of 4. And then I keep my denominator of 3. And if you look at what we did before, then that's exactly what we did. We ended up with 4/3, and we subtracted. Right? So it's just a shortcut that you can do. That way you don't have to borrow and then add 3/3 to it and then get 4/3. You can just do this process. This is on Canvas for you under your announcements so you know how to do it. But when I do it, then I have to ask, can I subtract my fractions? Yes. What do I have to have? My common denominator. Do I have it? Yes, I do. What do I do with my denominator? I keep it, and then I'm going to subtract my numerators. And 4 minus 2 is 2. So I know my distance, finally, we get to it, is 2/3 units. All right, so now I'm looking at this particular set, and it tells me that I have S and I have T. And when I'm looking at them, I'm trying to see, do I have the same X axes or do I have the same Y axes? And I have the same X axes. So I'm going to keep my X coordinates and I'm going to ignore them. I'm going to do my math with the Y's. And therefore, since they are opposites of one another, then I have to think about what math I'm going to do. Since I have one positive and one negative, then that tells me I have to do what mathematically? I'm going to have to add them. So since they are opposites, I find the absolute value of 5/10, which is 5/10, and I find the absolute value of negative 5/10, which is 5/10 as well. And when I add 5/10 to 5/10, I'm adding my decimals. Then I can bring down my decimal, and 5 plus 5 is 10, carry my 1, and I end up with 1.0. But we just say it as 1, right? 1 unit is my final answer. All right, so you try this one and then come back and check, and we'll see how we're doing. So you have vertical distances. We're looking at our 3 steps. We already have our ordered pairs. I want to compare my X and my Y. I see that my X's are the same, so I simply keep it and ignore it. So I'm going to do my math with my Y's. I see that I have one positive and one negative. So if they're in opposite areas, they're in opposite quadrants, then I know mathematically I have to add them. So I'm going to find the absolute value of 1.5, which is 1.5, and the absolute value of negative 2, which is 2, and I'm simply going to add those together. So once again, when I'm adding whole numbers and I'm adding decimal numbers, I need to make sure that my whole number has a decimal with it, and I line them up, and then I fill in with zeros. Once again, we're reviewing back from lesson 3.3 A and B, I think. so that we know how to work with decimals. Bring my decimal down, and 0 plus 5 is 5, 2 plus 1 is 3. So we figure out that the distance between E and F is a positive 3.5 units. All right, what about word problems? Well, what about it? Don't make them complicated. That's my biggest suggestion every single time when it comes to word problems. Read it, think about it, and then go through the process that's indicated that we need to do. Fritz and Manolo like to skateboard together at a nearby park. They want to determine who has to walk the farther distance to get to the park. So they graph the locations on a coordinate plane with the city's main square at the origin. The coordinates for each location are shown in the table. Each unit represents a city block. Who has to walk the farther distance to get to the park? So when we're looking at the park and we're looking at two different people, then we have to find the ordered pairs for two different people, do the calculations, and then we can compare them. So we're going to start with Fritz, right? So we're going to use Fritz's coordinates with the park coordinates. So when I'm looking at them, I want to be able to do the math. Then I'm going to find the distance for Manolo. I'm going to use his coordinates and the park's coordinates, and then I can do my comparison between the two amounts to see who has to walk the furthest. So let's start with Fritz and the park. So when I'm looking at their ordered pairs, I compare to see if I have the same X or the same Y. I have the same Y, so I'm going to keep it and ignore it. I'm going to do my math with my X. Notice that I have one positive and one negative. And if I have one positive and one negative, then that tells me that they are opposites and I need to add them together. So if I have the absolute value of negative 2 1/2, which is 2 1/2, and the absolute value of 3, which is 3, I want to add those together. Once again, I stack my whole numbers, I stack my fractions. 1/2 plus nothing is simply 1/2. 3 plus 2 is 5. 5 1/2 is my answer for them. Now, when I go back to the information in the word problem, it says each unit represents a city block. So we don't want to put units, right? We want to put blocks. But now, so since we know that Fritz has to go 5 1/2 blocks to go to the park, now we need to figure out how far Manolo has to go, and then we can compare our answers. Once again, comparing answers means we're going to find which one's greater than or less than. So as I start doing Manolos, then I have to look at the ordered pairs. I'm looking to see, do I have the same X or Y? I have the same X. So I'm going to keep it and ignore it. And now I'm going to focus in on my Y's. Notice I have a negative and I have a positive. Once again, knowing what my steps are, since I have opposites, then I know I'm going to have to add their values together. What values? Their absolute values. So I'm going to take my negative 3 3/4, and I'm going to find its absolute value, which is 3 3/4. And then I take my 2, and its absolute value is simply 2. When I add mixed numbers, I stack my whole numbers and my fractions. I see that I have 3/4 plus nothing, which is 3/4, and 3 plus 2, which is 5. So we're saying that we have 5 3/4, which is how far Manolo goes. All right, so he goes 5 3/4 blocks. So we're comparing 5 1/2 and 5 3/4. Now, once again, going back and reviewing, can I just compare mixed numbers if I don't have the same denominator? No, I can't, right? So I have to find a common denominator. Some of you will see that you can just double the 1/2 and you get a common denominator. But once again, the steps that will always work is I can multiply by opposite denominators. So that's what we're going to do because that process will always work. So on the left, I have a denominator of 4, which means I carry it over, and I multiply 1/2, top and bottom, each by 4. That's going to give me a new fraction of 5 4/8. So in order to compare them, once again, I have 5 4/8, but now I need a common denominator on the left-hand side. On the right, I have a denominator of 2, so I'm going to carry it over, and I'm going to multiply the 3 and the 4 each by 2. which is now going to change that one into 5 6/8. Now I have the same denominator. Can I compare fractions with the same denominator? I sure can. I have the same whole number. I have the same denominator of 8. So now I have to determine which is smaller, the 4 or the 6, because the arrow always points to the smallest number. The 4 is smaller, right? So if that is my smallest value, then who lives closer or who has to walk further, which is what we're being asked. So I'm looking for who has to walk further, which is Manolo, because he is the 5 6/8. So the answer is Manolo. Now it might ask you, well, how much further, right? Or who lives closer? We have to make sure we understand what we're being asked to answer when we do our questions. All right, so here we have this one. Well, Fernando has a dog walking job and will walk the dogs from his house to one of the 2 parks shown. He wants to go to the park that will give the dogs a longer walk. Which park should he go? So we're looking for the parks. We're looking for his house. We're comparing those distances. So we have to start with figuring out, number one, what is the distance to the Cobblestone Dog Park? So from Fernando's house, we're going to use those 2 sets of ordered pairs. Then, once we have that answer, we're going to compare it to the answer for the Bloom Limestone Park. When I compare them, then I want to figure out which one is further, which one is a greater distance, and that will be my answer to this one. So let's go through the math steps. I see between Fernando's house and Cobblestone Dog Park that I have the same y-axis. Therefore, I need to keep it and ignore it, and I do my math with my x-axis. Now my x's, I have one positive and one negative. Those are opposites. Therefore, I know since they're opposites, I'm going to have to add their distances together. When I look at their absolute values, then I have negative 2 1/2. I have 1 3/4. All right, so I've got you started. I want you to finish it and see what you come up with, and then check your answers with me. So hopefully you have an answer and you've continued where I left off. So you said, well, Mr. Barker told us that we had to add these 2 together. So if I add my absolute value of 2 1/2, that's 2 1/2, and I add my absolute value of 1 3/4, which is 1 3/4, then I have to remember that I cannot add fractions that don't have the same denominator. So that's why I paused and wanted you to try it, because I wanted you to go back to the previous question and review how you come up with a common denominator. So if you have 2 1/2 and you're trying to add 1 3/4 to it, then you just multiply by opposite denominators to come up with a common denominator. At the bottom we have a 4, so we're going to go to the 1/2 and we're going to multiply by 4s, which gives us a new top number of 2 4/8. And then my top denominator is 2, so I'm going to drop down to the 3/4 and multiply each of those by 2. And that's going to give me a new fraction as well. So I have my 2 4/8 and I have my 1 6/8. Now that I have my common denominator, can I add my fractions? Sure can. What do I do with my common denominator? I keep it. Then I add my numerators, and 6 plus 4 is 10. And then 2 plus 1 is 3. But now when we see that, we know that we can convert the 10/8. So if I convert the 10/8, right, I don't want to keep it. I know that, excuse me, 8 will go into 10 one time with how many left over? Well, I'd have 2 left over, right? So I have 2 8s. But 2 8s can be reduced. So we have to reduce where we can. So if I have 1 plus 2 plus 1 is 4 and 2 8s, now, so we're going to keep our original one, excuse me, as 4 and 2 8s. And you'll see why here in just a moment, but sometimes it doesn't really benefit us to reduce our fractions when we're not having to write that as our final answer. So I'm once again going to get you started on this one. I'm going to ask you to finish it, and then we'll see how you did. So you're going to use Fernando's in the Blue Limestone Park. You're going to look at your x-axes and see that they are the same. So you're going to keep it and ignore it. And therefore, you're going to do the math with your y-axes. Notice you have one positive and one negative. So think about the math you're going to do. You're going to have to do what mathematically since they're opposites. Hopefully you thought I'm going to have to add them together, which is correct. So I want you to do that, finish that one up on your own, and check and see how you did. All right, so hopefully you went through the process of the second set, and now you're seeing that you have 2 1/4, negative 1 1/2. You know you have to add them, so I need their absolute values. The absolute value of positive 2 1/4 is simply positive 2 1/4. And then the absolute value of negative 1 1/2 is positive 1 1/2. So when I'm seeing those and I know I have to add them, then I have to stop myself because I cannot add them unless I have a common denominator. Once again, I'm just going to add with or multiply by opposite denominators instead of just trying to keep it as the 4. Notice I'm going to end up with an 8 as a common denominator again, which is why we just kept what we had. So my bottom denominator is 2. I go up to the top and I multiply 1/4 by 2 and 2. That's going to give me 2 and 2/8. My top denominator is 4. So we're going to go to the bottom. We're going to multiply top and bottom of 1/2 by 4s. That's going to give me 1 and 4/8. So when I create my new numbers, I end up with 2. Well, that's all out of whack there, but 2 and 2/8, and I'm adding 1 and 4/8. Once again, I'm going to keep my denominator. I add 4 and 2, which is 6. 2 plus 1 is 3. Well, if I just look at my whole numbers, I can see which one's bigger and which one's smaller. So if I'm comparing, then once again, my arrow points to the smallest number, so it's going to point to which one? The 3, right? Because 3 is smaller. So is that my answer? Is Blue Limestone Park my answer? No, because once again, it says that he wants to go to the park that will give the dogs a longer walk. And therefore, my answer is the larger value. It's the Cobblestone Park. Right, we got it? So it's just making sure we follow those two main concepts. If my axis that is different has the same, they're in the same quadrant, they're both negative or they're both positive, then I'm going to subtract their absolute values. If they're in opposite quadrants, in opposite locations, one is positive and one is negative, then I'm going to add their absolute values. Those will give me my distances. All right, so you have your assignment. You can come and get it from me. And then if you have any questions, please ask. But don't forget, on Canvas announcements, I've given you the shortcut so you can remember the shortcut of finding a new numerator when you have to borrow fractions.